Hi everyone, so I continue on the lesson review 3, and this is video number 3. So here we have a physics question. I'm not going to talk about physics part, we are just going to do math part. So a fundamental equation of thermodynamics, which is this equation below, is a linear equation. So that's like a line that relates delta G to absolute temperature. Okay, so like when we say, so for example, y equal mx plus b, here also delta G is going to be related to T somehow. Okay, the equation is delta G, so minus delta S T, okay, plus delta H, and it says it relates delta G to T. Okay, so means whatever value I give for T, then I can find delta G. Okay, so here if I can just make a relation, so this is like a slope here, and this is like X here, and this is like Y intercept. Okay, so that's like a slope here with the negative sign, and that's like Y. Okay, so if you want to just picture it, okay, just you want to understand what's going on here. Okay, so here delta T is changing, and then we can find delta G. Okay, using above equation, delta G at 400 Kelvin. Okay, so means I am giving you 400 for this one. Okay, so you can find delta G for T equal 400 Kelvin, and in which delta H is 61 kilocalorie, and delta S is this value kilocalorie per K. Okay, so we just have to sub in. Okay, and in this case we can sub in. So yes, that part is easy. You sub in, you calculate, you have your calculator. Yes, but we do the substitution and calculate, but I want us to be careful about the unit and understand something about unit. Okay, so here delta G is, so what is delta S here? Let me see. Oh yes, okay, so this one, yes, okay, which is kilocalorie per K, and this one is 400 K. Okay, and this one is 61, yes, kilocalorie, right? Okay, so what's going on? I want to just show you that the units are just going to be fine, and it will just cancel each other and will be fine. Okay, see, you can cancel K and K here, and then you have the same thing. You have kilocalorie and kilocalorie, and yes, that's fine, we can add them. Okay, so when you are doing these type of questions, word problems, yes, of course you sub in, you calculate, but be careful about the unit. You have to be careful about the unit. You have to show what is the unit. You have to show which units are cancelled with each other. Okay, so here this cancel with that, so delta G is minus this multiple this plus this, right? So let me see, yes, and then kilocalorie. Okay, which the result is 40, so 61, so the result is 61 minus, okay, so that's 53. Okay, this kilocalorie. Okay, and then you have to write a statement. So mathematically I can just sub in, calculate, but when you have a word problem, so yes, you have to find the value, but you have to be careful about the unit. You have to be careful about the statement, conclusion statement. You don't say the answer is 53 kilocalorie. No, for temperature, okay, so you can say for temperature equal, for temperature temperature 400 Kelvin, the delta G is 53 kilocalorie. Okay, and if I have more information about the physics part here, I don't want to go to more details. I can explain in the statement, because when someone is just reading the question and seeing my answer, okay, they can understand what was going on for the question. Okay, so a cost equation is known to be 10x plus 250. Okay, where x is the number of units produced. So I produce, for example, several units, and then that will be the cost that I have to consider for producing this many units. Okay, so what is the cost for 5,000 units, around to 4 significant digits? Okay, so y is 10 multiple 5,000 plus 250. Okay, which is 50,250. Okay, and the answer is already 4 significant digit. Okay, so what is the unit here? What is the unit for the cost? Is it dollar? It didn't say. Okay, so it didn't say. So don't just add any units. So you can say the cost of producing 5,000 units is 50,250 unit of currency, but we don't know what. Okay, make sure to add the sentence. Okay, so homework is for the conclusion, which I just said. Okay, so describe the graph of an equation with a slope which is greater than 1. If the slope is greater than 1. Okay, so here I want to just talk about this question. This question doesn't have a, like, for example, a unique answer. Okay, because I'm not finding a value for something. This question is discussion question, and for this kind of questions you just discuss and consider different situation, and for example, less than, more than, you consider all of those things. Okay, and there is no unique answer for this question. Okay, so here you discuss, and these questions are really, so they happen so many times when you are doing, for example, courses in math. Okay, so maybe not for you for too many times in the college, but when you discuss on a question, you just brainstorm, you just bring your ideas to the question, and you just think about different situation and talk about different situation. Okay, so here it says describe the graph when the slope is more than 1. Okay, so I like to talk about, for example, a slope equal 1 and less than 1 and more than 1. Okay, so what is a slope? What is a slope? A slope is rise over run. Means changes on y over changes on x. Right now I can show you delta because you learned delta means changes. So delta y is y2 minus y1, delta x is x2 minus x1. Okay, so rise over run. So look at this here. I can show you on a just graph. Okay, if I have y equal x plus b, means if m is 1. If m is 1, for example, and b is, for example, if b is 0, okay, so let's just consider b is 0. Okay, so for example, b is 0, let's just consider that. Okay, so if m is 1, I have y equal x. Okay, so I can show you here y equal x. Oh, okay, so y equal x means, for example, if x is 1, y is 1. Okay, if x is 2, y is 2. So it's exactly here. Okay, this is y equal x. Okay, how about if m is more than 1? If m is more than 1, okay, so m is more than 1 means rise over run. Rise over run is more than 1, so means rise is bigger than run. So means when I go to right, I go more up. For example, m is 2. Okay, I go 1 unit to right, I go 2 units up. Okay, so the line is here. The line is just left to this line. Okay, so this one, for this one is y equal mx and m is more than 1. Okay, so I can just show this here. Okay, so look at this, for example. Okay, so for example you start here, you go 1 unit to right, but you can see you go 2 units up. Okay, more up, so rise is more than run. So rise is more than run. How about if I have m less than 1? If I have m less than 1 means run is more than rise. So when I go, for example 2 to right, I go just 1 up. When I go more to right, I go less to up. Okay, so what I go to right is more than what I go up. Okay, so here is this one. See, for example, I start from here, I go, for example, I go here like 2 units and I just go less up. Okay, in this case m is less than 1, so this is y equal mx and m is less than 1. So these questions are kind of just this discussion question. And okay, here, so here I can say run is more than rise. Okay, or I can say delta x is more than delta y. Change on x is more than change on y, but there delta y is more than delta x. Okay, so I cannot just say, okay, so describe the graph of an equation with the slope which is greater than 1. Okay, so I can, so greater than 1, so then, so for example, so what is greater than 1? So I cannot explain that unless I explain what does m equal 1 mean, and how about m less than 1 mean, and then I can talk about m more than 1. Okay, so you can see all of them here. Okay, so again, I want you to understand what's going on here, and I don't want you to memorize. When you have y equal x or y equal x plus b, doesn't matter. Okay, you just find b on y intercept, but m is equal 1 means whatever you go to right, the same amount you go up. Okay, more than 1 you go to right, but you go more up. So the line is left to the highlighted one, highlighted line, which is y equal x. But if m is less than 1, okay, so m is less than 1 here, so I can change the color to green. M is less than 1, you can see that the line is right to the highlighted line. Okay, so now I continue to the next question. What is the slope of a horizontal line and y? Okay, so you have to show a horizontal line, any horizontal line, doesn't matter, and you don't need to show it up for sure, you can show it down, doesn't matter. Okay, but what you see is, okay, I'm talking about a slope. For a slope I need 2 points. Okay, so I make 2 points, then I say I don't know x and y for each point, doesn't matter. This is x1, this is x2, but this is y1 equal y2, are the same. Okay, so a slope is y1 minus y2, which are the same, x1 minus x2. So I have 0 over a number. So yes, a slope is 0. And that's it. I don't need to give you the line. I don't need to give you all the points. See, here is also like discussion question. I just write it, I just picture it, I just talk about it, because I know a slope is change on y over change on x for 2 points from the line. Okay? How do the slopes of perpendicular lines compare? Perpendicular lines are compare. Okay, so here we talked about that. So this is L1, this is L2, and a slope of L1 is minus 1 over a slope of L2. So you have to flip and change the sign. These are perpendicular to each other. So yeah, okay, so these are the important points that you need to know. So give two, okay, so it says give two basic characteristics of an equation which graphs into a straight line. Okay, the first characteristic that I can talk about when I say a straight line, okay, means linear. It is linear. Linear means degree is 1. What does that mean? Y power 1, x power 1. And I don't see y power more than 1. I don't see x power more than 1. I don't see x and y in multiplication. What is degree? So for example, degree of 10x squared y cubed plus 5x squared minus 3y cubed is 5. How do I know? So see, I look at the highest one. The highest one is, you look at each term and you add all the exponents for each variable in that term. Okay, so here this is 3, here this is 2. So you look at each term and add all the exponent for all the variables in the term. And here is 5, so the degree is 5. Okay, in the line the degree is just 1. So x power 1, y power 1, not more than 1, and not xy. You don't see xy. If you see x multiple y, that's not a line. That's a curve. Okay, so the degree is 1. So the degree of a line is 1. Okay, so another characteristic I can talk about is, for example, if I have y equal mx plus b and m is more than 0, okay, so the line is like that. M is less than 0, the line is like that. If m is equal 0, the line is like this. Okay, and if, so do I have a space here? Yes, I do here. Okay, so if m is undefined, okay, so the line is vertical. Okay, if an equation is solved for x and it is it explicit or implicit? It is solved for x, so it is explicit because it is isolated for one of the variable. Okay, so it's explicit because, so these are just practice for you to just remember all those terms and just for future. Okay, so nonlinear equations. How do we graph nonlinear equations? Okay, in future when you learn more about functions, more about limits, derivatives, maximum, minimum, you learn how to graph graph any function. Okay, of course graphing in function is not a very easy, for example, for some functions it's not very easy. Okay, but you learn so much thing about how to graph because you learn so many things about a function. But right now the only way that we have is table of values. Okay, so you use a software, for example, that the software is using table of values, or you can use table of values on your own. Means you give some value to x and you find y. But in this case you have to have a good understanding of what to give to x. Okay, because it's not a line, it is a curve, and you want to show the curve, you want to show the most important part of the curve. So you need to know just have a good understanding of the domain of the function. Means what values you are allowed to choose for x. That's domain. Domain is just values for x and range is values for y. Okay, so in this case you can see just y equal x squared, y equal x power 3 cube, and then this one then this one, okay, radical, and then a circle. Okay, so these are not really hard to hard to graph them, because it's just they just go through 0 and 0, they just touch the origin. Okay, so it doesn't matter. Here you do x, here you do y, you give some values to x, you find y, and then you find those points there. Okay, but if you are doing, for example, some more complicated functions, for example, x plus something, minus something, power something, so these things you need to have a good understanding of the domain. And maybe if I want you to graph it, I give you the domain, I say, okay, choose values from this domain. Okay, but here doesn't matter, so I choose -2, -1, 0, 1 and 2. Okay, -2 squared is 4, 1, 0, 1 and 4. Oh, okay, I have the same values for -2 and 2, the same values. Okay, okay, so now I want to graph it. How do I graph it? Okay, do I need positive and negative for x? Yes. Do I need negative for y? No. So I don't need to bother myself. I don't need to do this, because I'm not going to use this part. I don't need, okay, graphing techniques. So I use this, because I don't need negative for y. Okay, so this is x, and in the middle, and that's y. Y in the middle, because I need positive and negative for x. Sorry. Okay. Okay, do I have a space? Yes. So I do 1, I do 2, I do -1, I do -3. So I go 3 by 3. How can I go here? Okay, so 2 by 2, because I need to go to 4. Okay, 1 and 4. So here I go 2 by 2. Okay, so 1 and 1, 2 and 4, -1 and 1, this and this, and then this and this. Okay, so now you connect them. But if I have a good understanding of a quadratic function, which is for example x squared, or for example x minus 2 squared, or x plus 2 squared, or x squared plus 5, for example, this kind of functions, then I can be sure, okay, the graph looks like this. So you need to know, when you have quadratic, the graph looks like parabola, which is this way. Okay, so perfect, I'm right. Okay, so how about this one? How about this one? Again, the graph passes through 0 and 0. Okay, so I can choose x equal -2, -1, 0, 1 and 2. Okay, so -2 cubed is 8, sorry, -8, -1, 0, 1 and 8. Do I have negative and positive on x? Yes. Do I have negative and positive on y? Yes. So I need to show all parts, 4 parts. Okay, so do I have room here? Yes, 1 and 2. Okay, 3 by 3 I go. How about here? Here I don't have room, so I don't have even room to go 1 by 1. I can go half by half, because I need to go to 8. Okay, so this is 8. The previous one is 6, 4, 2. Okay, so, and here I do 2, 4, 6, -8. Okay, so -8 and -2. Okay, so now -2 and -8, -1 and -1, 0 and 0, 1 and 1, this and this. Okay, so I do this way. And again, if I have a good understanding of cubic function, which is power 3, for example, x minus 2 power 3, or x plus 2 power 3, or x cubed, for example, plus 5, or x cubed minus 5, if I have good understanding, so it's very good for my for your future, if you have good understanding of how quadratic looks like, how cubic looks like, and you can see it here. Okay, Okay, so y equal 1 over x. Oh, okay, so does it go from 0 and 0? No, I cannot choose 0 for x. No, that's not my domain. Listen, that's not my domain. So here my domain is R. I can choose any value, any value for x. I can choose any value for x here. So my domain is R. Oh, perfect. So I can choose any value for the number 1 and number 2. But here, no, domain is R minus 0. I cannot choose 0. Okay, so I go here, I go here. Can I choose negative, positive? Yes. Okay, so I do minus 2, minus 1, 0. I don't. 1 and 2. So minus 2 when I do is minus half, minus 1, 1 and 1 over 2. Okay, so now I can graph it. Again, this one, if I have good understanding of this, is good. So for example, okay, so for example, if I do, let me see, 1 and 2. Okay, so when I do 2 is half, so okay, do I have a space for? Yes. Okay, so I go here. Okay, so 1 and 2, minus 1 and minus 2, and here I do, for example, I can say this is 1 and this is minus 1, and that's half and half. Okay, so 1 and 1. Okay, so 2 and half here, and here minus 1, minus 1 and minus 1, and okay, minus 2, and this, so here. Okay, so this one and this one. Okay, so here maybe it's not bad. Here maybe it's not bad that you just for example use a graphing for example app. Okay, graphing application, graph it online, but it's not bad that we discuss something here. Okay, look at this. When x approaches to 0, what happened when x approaches to 0 here? Okay, when x approaches to 0, for example from right side, for example x is for example if x is 0 point so like this, so 10 power, for example 10 power minus 4. Okay, what is y? Y is 10 power 4. Okay, because you flip it. Okay, oh okay, so when x is very small, y is very large. Oh okay, so I can graph it this way. Okay, it goes up. Okay, yeah. How about when so x approaches to a very large number? Oh okay, when x approaches to very large number, for example this, y is very small. Oh okay, so when x is approaching to large, y is very small. The same thing here. Okay, when x is approaching to so very small number in negative, okay, which is here, very small number in negative, which is here. Okay, y approaches to a very large number in negative, so it goes like to, so like this. And when x is approaching to somehow a very large number in negative side, okay, so y approaches to a very small number in negative side. Okay, so that's a good just a good picture, or just a good graph for this function here. Okay, so and it's not bad that we keep these pictures in our mind. So for x squared looks like parabola, for x cubed it's like this, somehow like a n or a z, for example, but it depends on so for x plus or x minus or minus beside, or what is the value beside x cubed, so it can change. This one as well. How about y equal x or y equal radical x? Okay, what is the domain? Again, I talked about the domain. Can I choose negative values for x? No. Can I choose 0? Yes. Okay, so I cannot say I choose minus 2 and minus 1 because I like it for x. I can't. So I have to do 0, 1, for example 4 and 9. What is radical 0? 0. Radical 1, 1. Radical 4, 2. And radical 9, 3. Okay? And then you can graph it. Do I need positive on x and y? Yes, just positive. Okay, just positive. Okay, so here is 0. Here is 2, 4, 6, 8, and 10. Okay, so if I do, okay, so here is 1, 2, and 3 here. So if I do 9, it's 3. If I do 4, it's 2. 1, so 1 and 1. Okay, so that's 1 and 2. Okay, yes, and 0, 0. Okay, so it looks like this. Okay, so it's very good that we know something about the domain to see what I can choose for x. I cannot choose negative for x because it's radical. On the radical I cannot have negative. It goes to it goes out of real numbers, imaginary numbers, and I don't want to go there. I want to just stay with real numbers. Okay, so these, and then the last but not least is a circle. Okay, so the circle here, so as you can see, okay, I can show you why do I say this is a circle. A circle is, the equation looks like this. Okay, this is a circle with the center of the circle is A and B, and the radius of the circle is R. Okay, so now you can give some values to x and find y. Okay, so x minus 2, minus 1, 0, 1, and 2. Okay, so here if I have x equal minus 2, so x equal minus 2, okay, y is 0. If I have x equal minus 1, so then I can say, okay, so y2 is, okay, so minus 1 plus y2 equal 4, and then y2 is equal 3, and then y is plus minus radical 3. Okay, plus minus radical 3. You learned this last semester. Okay, so how about 0 here? So when I put 0 for x, then y is plus minus 2. Okay, when I put yes, because y is, see, when I put 0 is y2 equal 4, and then y is plus minus 2, y is plus minus 2, and then y is, okay, and if I do x equal 1, then y is plus minus radical 3 again, and if I do 2 is 0. Okay, see what is the reason? The reason is y x squared plus y squared equal 4. Okay, y squared is 4 minus x squared. So y is plus minus radical 4 minus x squared. Okay, I can talk about this, which is not a function, but I will talk about it later. Okay, so you have y equal positive and negative values, so that's why. So now you can graph it. So now you can graph it here. So look at this. Okay, so for example, I can have let's say, okay, so for example, I can have 1 here and 2 here and minus 1 and minus 2. Yes, and the, do I have a space? Okay, so because I don't have a space, I go 2 by 2 because I don't have a space for all parts. Okay, so 1 and 2, 1 and 2, minus 1 and minus 2, and 1 and 2, minus 1 and minus 2. Okay, so minus 2 and 0, 2 and 0. Okay, so this and this, and then for values of minus 1 and 1, so I can find those values, and then I can see this is the circle. Okay, So when I have -1, y is plus minus radical 3, and radical 3 is, I think, 1.7. Yes, 1.7. So it is almost here and here. And then, for example, for this one, 1 is almost here. Yes, and almost here. Okay, so then I can just graph it, and that's a circle. Okay, again, it's good that we have this in our mind, that a circle looks like this. Okay, so a circle equation looks like this one, and then I can say this is the center of the circle, this is the center of the circle, and that's radius. Okay, here the center of the circle is, what is the center of the circle? 0 and 0. Oh, okay, which is here. What is the radius? The radius is 2. Okay, which is this. Okay, this is the radius. Then I can give values to x and find y. But I have to make sure that I know for -1 to 1 and many x, for many x, so almost for many x, so when I, so almost for all of them. Okay, so except for example -2 and 2. When I give values, any value to x, I have 2 values for y, and yes, this is here. Okay, that's for 1 and that's for -1, plus and minus. Okay, and then I can see, oh, okay, I can just connect all those points to each other, and that's a circle. Okay, so we are done with review number 3. So I wanted to just give good understanding of the last semester. So if you feel you need some more practice, make sure to do more practice. You really have to be good in algebra for math 273. You really need to be just good in math 171 to do best in math 273, and you better start now. Okay, so the next we continue to topic number 1. Thank you. Bye.